Hello, I am Himanshu Kumar and welcome to the presentation of our Dynamics of Machines term project. The topic of our presentation is Analysis of IC Engines. This project is being presented by Himanshu Kumar, Shourya Sharma and Shaurabh Tiwari. Now let us begin with a brief overview of IC engines. An internal combustion engine or IC engine is a heat engine in which combustion of fuel occurs with the help of an oxidizer, usually air, inside a combustion chamber. The air fuel mixture is compressed and then ignited. This leads to high pressure and temperature buildup inside the chamber. The high pressure acts upon the piston and is responsible for generating its motion. The piston is then connected to a crank via a connecting rod. Thus, the IC engine is essentially a 3R 1P chain, with the piston acting as the slider. As the piston moves, the crank rotates, producing work. This process is carried out in a cyclic manner, thereby converting chemical energy into mechanical energy. Based on the method of ignition, the IC engine can be classified into two types: the combustion ignition engine and the spark ignition engine. In the combustion ignition engine, the air fuel mixture is compressed to such an extent that it ignites itself, while in the spark ignition engine, an external spark plug is provided that ignites the air fuel mixture. Now, let us talk about the ground shaking forces. The IC engine is a machine whose components are always in motion. Thus, during various points in the cycle, it is possible that dynamic forces and moments may arise due to this movement. These forces and moments are known as shaking forces and shaking moments. These factors are responsible for the vibrations during the motion of the engine. These vibrations may lead to wearing of various engine components and the engine noise. The vibrations can be reduced by balancing the engine and using engine mounts of proper specifications. The engine mounts should have high stiffness and high damping in the low frequency range, and low stiffness and low damping in the high frequency range. Now, let us have a look into balancing of IC engines. As we already know, due to the shaking forces and moments, vibrations arise, causing noise and wear. Engine balancing is a method to reduce these vibrations. It employs techniques in the frequency and time domains to power balance the IC engine. It essentially tries to balance out the net dynamic forces and moments arising during the motion of the engine at every point in the cycle. If the engine is unbalanced, the motors overload, causing damages to the motor itself and eventually engine failure. In the following slide, we have listed some advantages of balancing in IC engines. Balancing essentially reduces the vibrations to a minimum, which in turn reduces the noise of the engine. Reduction in vibrations reduces the amount of wearing of various machine parts, which maximizes the engine life. Balancing maximizes the efficiency of the engine, optimizing the fuel usage and reducing the energy wastage. As the fuel usage is optimized and vibrations are reduced, the output of the engine is also increased. Now, let us proceed to the model of an IC engine prepared by our group.
This is the model created by our group using MATLAB. On the right side of the screen, we can see how the 3R1P chain moves inside the IC engine. As one can see, the piston, that is the slider, moves up and down and the crank rotates along with it.
Now let's start with the analysis of IC engine using Python. This is the code for SymPy for the simulation. Now, coming to the code, K is the stiffness, Kr is the radius of gyration, EV is the offset, F1 is torque, and F2 is the external friction force. Now, for an IC engine, offset is equals to 0. Now, using that idea, we calculated the following forces and applied the equation of motion. Using which we find the equation for all the motions. Coming to the plots. This is the plot for variation of theta versus time. This is the plot for the variation of s with time. This is the plot for variation of angular velocity with time. This is the plot for the variation of linear velocity of piston with time. These values are in accordance with an actual IC engine. Now, considering the ground shaking force. To calculate the ground shaking force, we use the equation of motion and solve the free body diagram, using which we calculated the ground shaking force in the x direction and in the y direction. Now, with the flywheel, we calculated the energy. Like the energy in the flywheel after combustion is half Pmax A into S, out of which a significant portion, about 1/6 of it, is lost due to friction. This is the equation of the tau F, the force value along x, and the force value along y. This is the equation. Thank you. I would like to thank Professor Anirban Das Gupta for providing us with such a wonderful project which helped us to strengthen our concept in dynamics of machine. I would also like to thank him for his guidance and supervision regarding the project. Thank you.